here we need to find, given the length of a vector and an angle, we need to find what the x component is and what the y component is. So first of all, we need to make a couple of notes about what we expect our data to look like. So if we establish our coordinates, we know that 0 degrees is right here. We have 90 going straight up, 180 to the left in the negative x direction, and 270 degrees going straight down. Whenever we complete a full circle, we also have 360 degrees. So looking at this vector, we know that we are in the third quadrant. We also know that we're expecting a direction somewhere between 180 degrees and 270 degrees. Now, even though we're provided with this angle of 50, that's not the total direction all the way around from 0 degrees. So we know that we have 180 degrees and that we went 50 degrees more. So we actually have a direction of 230 degrees. And then we know the length of our hypotenuse is 16 meters. Now we know that to get this arrow to where it was, it had to go down and to the left. So we'll go ahead and draw our horizontal displacement. So we move to the left, we know that our x should be negative and our y should also be negative. Now notice here, whenever we find our x and y components, we'll have a nice little right triangle. Alright, so we have our direction, we have our hypotenuse, and we know that x equals the hypotenuse cosine theta. And our y equals hypotenuse sine theta. Remember, our theta is 230 degrees. If we used 50 degrees, the calculator is going to think that we're talking about 50 degrees from 0, which would give us a positive x and positive y. We know that both our x and our y are going to be negative since we had to go to the left and then downwards. So we need to use this entire direction from 0 degrees of 230, and it will give us the right coordinates for our displacement, for our resultant here. So our hypotenuse is 16. For x, our trigonometric function is cosine, and then our theta is 230. So we get, just as we expected, a negative number, negative 10.3 meters. We also expect a negative number for our sine because we went down. So we will say 16 sine 230, and sure enough we get a negative number, negative 12.3. meters. Alright, so we have now resolved our vector, which was 16 meters at a total of 230 degrees, into our x and y components, where x equals negative 10.3 meters and y equals negative 12.3 meters. Again, if we chose to use this original 50 degrees, let's go ahead and plug it in and just see what happens. So 16 cosine 50 and 16 sine 50. We get 10.3 and 12.3. So from the origin, you're really giving coordinates to go 10.3 to the right and 12.3 up, which is the exact opposite of where our vector is. So we need to use the complete and total direction from 0 going all the way around to our vector.